All right, in this, for example, same problem as before, same percentages that we were talking about. This sentence right here is really important, and a lot of you would probably miss out on what this is trying to tell you. But while dining in a campus facility open only to students with meal plans. So what that tells you is you are now being restricted. If this is where you are, and the people that are there all definitely have meal plans, that is a conditional statement. You now know that we are talking about only people with meal plans. So while you're there, you meet someone interesting, someone you would like to get to know better. What's the probability your new acquaintance also lives on campus? So what we're trying to do now is find the probability that you live on campus knowing you have a meal plan. It's different than just the probability of you living on campus general, because living on campus general would be out of everyone. But this is now only out of the meal plan group. And so we're using this formula that we have here, which is on our formula sheet. But we're basically just going to find all the people who have live on campus and have a meal plan, and just divide out of the meal plan group. We're just restricting our attention to the meal plan category. So that's going to be, this number is the 0.42 told to me in the problem. That's both. Out of the meal plan people, that's the 0.62. Getting 68%. So hopefully that formula kind of makes sense to you. That given means you're looking only out of that group now. So you want the people in the meal plan group that also live on campus, so that's the both, out of all the meal plan people. All right, when general multiplication rule. When two events A and B are independent, we learned last chapter that we can use the multiplication rule. Probability of A and B is just simply the probability of A times the probability of B. But remember, we could only use that rule if we believed the events were independent. Remember, independent meant A occurring had no effect on B occurring. Okay? But now, what do we do if the events are not independent? Just like we had to have a fix when the events were not disjoint for the previous problems, what do we do if they're not independent? So that rule is not going to work anymore. So once again, we're going to fix the old rule, and we're going to come up with a new rule called the general multiplication rule. Now, we actually just learned the formula for this. It is this formula. There's your A and B right there. We're just going to take this formula and rearrange it so that this is by itself. So we're going to multiply by the probability of B on both sides. And so what we're going to get is the probability of A and B is equal to the probability of A times the probability of B knowing A has occurred. So I want you to take a minute and kind of think about this. This is not on your formula sheet, but it is just the previous formula rearranged, which is on your formula sheet, okay? So all I did was rearrange that formula for the A and B part. So the probability of A and B is equal to the probability of the first event times the probability of the second event, knowing the first event occurred. That's what this is telling me. Now, if the events were independent, knowing this occurred would have no effect on B. So it would be just simply equal to just the probability of B. And that was our first formula. But now, if the events are not independent, probability of B might change knowing A has occurred. So you have to think about what that change would be. Independence of two events means that the outcome of one event does not influence the outcome of the other. With our new notation for conditional probabilities, we can now formalize this definition. So events A and B are independent whenever the probability of A given B just equals the probability of A. That's the same thing that's written here. What they meant to put here is the probability of B given A is equal to the probability of B. That's what should have gone in that blank. And this is the same thing. You're just switching what's A and what's B, but that doesn't matter because we could have called the other event A and this event B. So both of these are saying if this is true, so if this is true, then A and B are independent. You need to know this. This is how you can state, either one, it doesn't matter, that you think two things are independent. And you will probably be asked that. You will probably be asked, are A and B independent? And so the probability of B given A should equal the probability of B. And if you think back to chapter 2, when we did this in a slightly different way and we looked at conditional, there's that condition, conditional distributions, and we looked at segmented bar charts, and were they the same? That's what this is saying, is the probability or the percent of people in B knowing A has occurred, that's conditional. If that percent's the same as just B in general, that would have been like our two pieces of a segmented bar chart. Are those the same? That told us independent. So we were really doing the same thing, it's just a little more formal here. Our survey told us, same scenario, 56% live on campus, 62 at meals, 42% do both. Are living on campus and having a meal program independent? So now I want you to think back to just the previous problem that we did. Probability that a person lives on campus knowing they have a meal plan. We did that problem previously. I'll just real quick write it back down. The way we did that is we did campus in meal plan over just the meal plan group, and that value was 0.68. Now, they want to know, are these events variables independent? So we just did probability of C given M. So if you look here, if that is equal to the probability of C alone, the first one, if probability of living on campus knowing they have a meal plan, does this equal the probability of living on campus alone without knowing they're in the meal plan? So the question is, does that equal 0.56? Are those two numbers equal? No, they are not. So we say no, they are not independent. And basically what's happening here is 56% of all people live on campus. But when you restrict your attention to just the meal plan, that number goes up to 68% living on campus. So that means if you have a meal plan, you're actually more likely to live on campus. Now, if you know anything about colleges, that should make sense to you, because the people who live on campus are typically the people who get the meal plans. The people who live off campus and have their own apartments and kitchens don't really need a meal plan at the school because they can cook their own food. So it should make sense to you that they're not independent. There is a relationship. Knowing you have a meal plan is kind of tell me that there's a better chance that you live on campus than just in general. So hopefully that's kind of making sense, and you need to let that sink in. Second question, are they disjoint? We should already know this answer to this question, but basically you want to ask yourself this: does this equal 0? Does the probability of C and M equal 0? In other words, is there no one that lives on campus and has a meal plan? Well, guess what? No. There's 42% that live on campus. So they are not disjoint. You can do both. You can live in a meal plan live in campus and have a meal plan.